Guys, welcome back. Let us look at another example on finding the trig ratios or trig functions. Guys, in this example, what is already given to me is one of the trig ratios, and in this case, that is the tangent of beta. So tangent of beta is already provided to us. We had to find the other 5 trig ratios. So guys, a common confusion or common challenge that students find here is like they don't see a ratio here. But guys, keep in mind, if I have a number by itself, then it is understood that there is that invisible one like in the denominator. So the first thing that we just have to do here is we have to rewrite this tangent of beta as a ratio of 2 over 1, because 2 over 1 is simply 2. So we are not actually changing what is provided to us. Rather, we are just rewriting it in a way which is more like a user-friendlier way, which can help us to kind of go ahead and evaluate or find the other trig functions. Okay, so guys, once we have this, it is very similar to what we did in example 2, or for that matter what we did in example 1. From here, guys, we are going to draw a right triangle, and then even before drawing a right triangle, let us remind ourselves what is the tangent in terms of the sides. Guys, it is the ratio of the opposite over adjacent, which you can also see right here, SOHCAHTOA. And then based on this, I'm going to draw a right triangle for my reference. Guys, this is my 90-degree right angle, and let us call this as beta. You are free to choose this as beta or call this as beta, it's up to you. So if I call this as my beta, which is my reference angle, then this is going to be my adjacent, which is 1, and then the opposite is the length side, which is directly opposite to that angle, which in this case is going to be positive 2. So guys, I have the lengths of the adjacent and opposite. The first thing I have to do is I have to find the length of the longest side of this right triangle, which is basically finding the length of the hypotenuse. So to find the length of the hypotenuse, all I have to do is x squared is 2 squared plus 1 square, right? Using the Pythagorean theorem, it's 4 plus 1, which is 5. And when I take the square root, I get the h equals to square root of 5. So my length of the hypotenuse is square root of 5. I have all the 3 sides. Let us go ahead and write the trig ratios. Guys, I already have the tangent. Why don't I go ahead and first write the cotangent, because they are reciprocals of each other. So if tangent is 2 over 1, then cotangent being the reciprocal of the tangent, it's going to be just simply 1/2. Then the second one I'm going to write is the sine of the beta. Sine is the opposite over hypotenuse. Right here we can see that. So opposite is 2 and the hypotenuse is radical 5. But we don't like radicals in the denominator, so we have to rationalize the denominator. How do we do it? We multiply upstairs by radical 5 and downstairs by radical 5. It is 2 radical 5 over 5. That is my final answer for the sine of beta. Moving on to the, once I have the sine of beta, we should go ahead and we should write the value for the cosecant, which is the reverse or reciprocal of the sine. So let me write the cosecant of beta, which is the reciprocal of the sine. So it would be 5 over 2 radical 5, right? And then guys, again, I have a radical in the denominator, so I can multiply. I should multiply upstairs by radical 5 and downstairs by radical 5. What do I get? I get 5 radical 5, and downstairs I get 2 times radical 5 times radical 5 is just simply 5, right? Guys, I can multiply 5 times 2, that is 10. Then I can simplify, or I can already see that there's a 5 upstairs and downstairs. Just cross it out. It's radical 5 over 2. That is the final value. Guys, there's other way of doing it. We already know that the sine of beta initially was this, right? So we could have just used that, and the fact that this cosecant is the reciprocal of sine, so we could have just simply said that cosecant beta is radical 5 over 2, which is exactly the same thing that we got by using the final version of sine beta and then rationalizing the denominator. Okay, so there's both ways you can do it. Then guys, the fourth one is we have 2 more to go, the cosine of beta. Cosine is what? Adjacent over hypotenuse. Adjacent is 1 and hypotenuse is radical 5. So this is, we cannot leave it like that, right? We have to rationalize. So I'm going to rationalize by multiplying upstairs and downstairs by radical 5. It becomes radical 5 over 5. That is the cosine of beta. Then the last one that we have to find here is the reciprocal of cosine, which is the secant. And to find the secant, guys, you can go back here and reciprocate, then you will have to rationalize the denominator. But if you just use this form, then it's just going to be radical 5 over 1 or simply radical 5. So these are the 5 trig ratios given the tangent of beta equals to 2. So guys, it was very similar to what we did in example 2. The only tricky thing here was to realize the fact that if we have just a number by itself, then we have to bring in divided by 1, because that is not, by doing that we are not changing the number, but now we can see that there's a ratio of 2 quantities. From there we can say that we have the value for the opposite as well as the value for the adjacent, because we need the lengths for 2 sides to find the third side, and then from there we can write any of these ratios. Okay, guys, this is example 3. I'm going to show you many more. Till then, take care. See you next time.